Hello everyone. So if you have seen the previous videos in this playlist, I'm talking about this particular video. If you have seen this particular video, in this video we had this huge data frame which was highly balanced. In this data frame we had 6.3 million of records, out of which we had only this many fraud and this many non-fraud, right? If you see the proportion of fraud in this particular data, it was only 0.002, which is somewhere 0.02%. Okay, we can say that. And because of this, when we did the evaluation and when we created the model, our model gave us the accuracy of 99%, 99.8% rather, you can say. All right, so this means that whatever value you put, that will be approximately 100% correct. And do you know what, that will be, this model will always tell you that this particular record is no fraud. Let me show you why. So after getting this prediction, we did further deep dive and we came up with this kind of metrics. Now if you see, this is the largest volume which we have. So this apparently telling you what, this is something which is where the model is inclined. Okay, no matter what value you put for the features, supplied features, it is always going to tell you no fraud. Because if you see, this is something which is towards which the model is inclined. And if you look at this particular proportion, if you see, this model says that it's a no fraud, while this is actually a fraud case. So to explain it better, what we did is we created this kind of report where it has precision recall, F1 score, etc. right? And if you see, for no fraud, all these three KPIs were 100%, while for fraud, precision was 35%, recall was 41%, and F1 score was 38%, which is giving you a much better picture of your model performance, right? Now today in this video, this is what we are going to discuss about, what these KPIs are, what is precision recall and F1 score. Let me take you to the board and try to help you understand this. All right, so here these are our data points for sample, right? I have taken these data points. Apparently you can see these top 3 are fraudulent and bottom 4 are no frauds, right? So wherever we have fraud, we're gonna call that as positive. Okay, and wherever we have no fraud, we're gonna call that as negative. We are going to make this model from the perspective of frauds, right? Identifying the fraud. So wherever it identifies the fraud, we're going to say that it's positive, and wherever it identifies no fraud, that will be negative. Okay, now moving forward, hope this is clear. Moving forward, this is the data set we have, sample data set. Okay, now to evaluate this, we made a model. This is the model which we have. Now once this model comes into the picture, what it does, it creates an x-axis, and on that it puts the predicted values. Prediction will be fraud and no fraud. It will classify that in 2 categories, fraud or no fraud. How it does that? It picks one observation and classify that as fraud. Another observation, classified that again fraud. Then another, and model says it's no fraud, and then it take another data point and again says it's no fraud. Once this is created, what it does is it makes a metrics kind of stuff of this, right? Where we will, for simplicity, we will call fraud as positive and not fraud as negative. This is on x-axis, and on y-axis we're gonna put our actual values. So this is our predicted value, what you're saying at axis, and over here we are going to put the actual values, and we will also call it as positive and negative, same as we did over here. Now let's have a look at this particular data point. On this data point, if you see, this is predicted as positive, right? This is predicted as positive, and when you check the reality, so in reality also this is a fraud, means in reality as well it is positive. So our prediction of saying this, a positive element, is true. So in total we're gonna say that this particular data point is true positive. Why? Because it was predicted to be positive and actually it was positive. So that's why we call it true positive. Hope this is clear. Now let's have a look at this particular data point. Here we predicted it to be positive, but if you look at the reality, in actual it is negative. So our prediction of it being positive is false. So that's why we're gonna say it false positive. Hope this is very clear. Now let's have a look on this one. Here we predicted it to be negative, but if you see in the reality it is positive, okay, because here we are saying that it's not a fraud, while like you can see this is actually a fraud. So our prediction of saying it negative is false, so we're gonna say it false negative. Let's have a look at this particular data point. So here if you see, we are again predicting it as negative. Our model is predicting it as negative, while in reality it is also negative, right? So that means our prediction is true. So we're gonna say true negative. In total, these are the 4 predictions we got out of our model. Now let's put them in a box, and that's how it makes a 2 by 2 box. And this 2 by 2 table, and this kind of table is known as confusion matrix, in which on this diagonal what you see is generally correct prediction, and on this diagonal what you see is incorrect prediction. Okay, so this is the confusion matrix in a nutshell. Moving forward, let's again take this particular. Alright, before we move forward, let's understand these names and give an acronym of these names. I believe by now you are clear about what true positive, true negative, false positive and false negative, right? Now we are going to give an acronym to it. Wherever it is true negative, we're gonna say TN. Wherever it is true positive, we're gonna say TP, false positive FP, and false negative FN. Now here we have this data point, and we will be running our model on this. When we do so, model classifies these data points in 2 parts, which are fraud and no fraud, right? This is how it is classified. Now let's see from the fraud perspective, right, from the positive side. So for now I'm just going to hide this part, no fraud part, I'm just keeping it aside, and we will be focusing on fraud part only. Now on this fraud part, what we're gonna do is we're gonna find out how many points are correctly predicted as fraud. So if you see, these 2 points are correctly predicted as fraud. These 4 points are predicted as fraud, out of which only 2 are correct prediction, like you can see over here. So these predictions can be called as true positive, because these 2 points were predicted to be positive and actually these were positive. So that's why we call it true positive. Now if you have a look at these 2 data points, these are genuine, means no fraud, while the model says it's a fraud. So these data points will be referred as false positive. Now these 4 points, out of these 4 points, we're gonna take a proportion of accuracy. We will check out how many points are correctly predicted to be fraud. To do so, what we're gonna do is we're gonna create this kind of fraction, right? And as a denominator, we will take all the true positive points. So 1 true positive, then 2nd true positive, then we will also put all the false positive predicted values, which are these 2. Out of this, we're gonna check how many true positive are there. So apparently these are 2 true positive. This is very clear, please don't get confused. So here what we are doing is we are putting all the predicted points, which are 4, and we put all of them over here, simple. And over here we are putting only those data points which are correctly predicted. Now once you are done with, so if you see, there are total, here we are putting total number of true positive plus total number of false positive, and out of that we are going to check how many are correctly predicted. So this is the proportion which we are going to take. So if you see the numbers, the total number of true positive are 2 plus total number of false positive are 2. Out of that, the proportion which we want to check is for this one, so which is 2. So 2 by 4, which result in 0.5, or you can also say 50%. So this calculation is nothing but called precision. So in short, to be precise, the formula for precision will be true positive divided by total number of true positive plus total number of false positive. You can also say that in your prediction, whatever true positive you have divided by all predicted positive, right? True positive divided by all predicted positive. So the point which you should take care of is, which you should note is this, which is predicted. So remember, precision will always work on predicted data points and not on actual data points, right? So here, whenever you are calculating precision, as a denominator, we will always take all the data points which are predicted as positive. This is when we are calculating the precision for positive side. When we are calculating the precision for negative side, we gonna take all the predicted points which are predicted as negative. Okay, I just hope that this is pretty clear. Now that we have understood what precision is, I want you to pause the video and find out the precision for not frauds. So here what you require to do is take all the data points, and out of that check out how many data points are correctly predicted to be no fraud. That's what gonna be your precision. Moving forward, again we come on this time we are not going to, in first place we are not going to be focusing on predicted values. Let's check out how many of these all data points are actually frauds, not predicted, actually in reality how many of them are fraud. So these all are the data points are fraud in reality. Now prediction comes in the picture. Out of these three, like you can see, out of these all data points we have only 3 actual frauds. Now we need to focus out of these 3 how many are correctly predicted as fraud. So you get the answer that these 2 are correctly predicted as fraud and this one is incorrectly predicted as no fraud. So because we are doing this calculation again for fraud side only, not for no fraud side. Okay, so again we're gonna find the proportion, but this time, all right, so here this is true positive, this is also true positive, and this is false negative. This here our model said that it is negative, which is false. This is not actually negative, right? So let's see at the formula. This time we are going to do a different calculation, right? In which what we're gonna do is we're gonna take the count of true positive, which is 1, again 1 true positive, and then the false negative. Here we are simply taking all the data points which are fraud in reality, okay, not in prediction. Out of this, how many has been correctly predicted as fraud? So again, what we can do is we can take total count of true positive, which is 2, and out of we can divide it with total number of true positive plus total number of false negative, right? And when you see the number, this is what the number you get, 2 by 2 plus 1, which is 2 by 3, and the final result which you get is 0.66 or 66%, you can also say. So this was nothing but recall. So to be precise, the formula for recall is true positive divided by true positive plus false negative, which we can say that recall is nothing but it's a proportion of true positive divided by all actual positives, right? True positive divided by all actual positives. So the point which you should note is this actual. Here when we are calculating recall, the denominator which we're gonna take is actuals, not the predictions, right? So here so whatever your prediction comes out on actual, either your prediction will be positive or it will be negative. That means either that will be true or that will be false, right? So you can take false positive plus true positive plus false negative. That is your total volume, right, of fraud. I just hope that it is clear. Now that we have understood recall, I want you to pause the video again and find the recall for not frauds. We just calculated recall for fraud. Now I want you to calculate it for not fraud. After understanding both of these two things, let's have a comparative look. If you focus on precision, like I said, that it takes predicted points as the denominator, while in recall, actual points are taken as denominator. I just hope that it is clear. Just in case of any doubt, put that into the comment section. I'll be very happy to clarify that. Now we are done with understanding precision and recall. The time comes in when we should focus on F1 score. What is F1 score? It is nothing but the harmonic average or harmonic mean, you can say. F1 score is nothing but the harmonic mean for precision and recall. So the formula goes like this: 2 into precision into recall divided by precision plus recall. When you impute the value of precision and recall into this formula, this is what you get, and when you solve this at the end, you get this value, which is 0.57, or you can also say 51.7. So F1 score is a technique to balance between precision and recall. I just hope that it was clear to you. Now coming back to our model over here. Now if you read out precision, recall, F1 score, you must understand the significance of these numbers. 38% F1 score is telling you how good your model is in predicting the frauds, right? So it is predicting the frauds correctly only by 38%, right? And when it comes to predicting no fraud, it is working 100% well, right? So this is what we got in classification report, and we try to fix that in this particular exercise, which I covered in this particular video, right? In the second part I have covered this particular thing. So in this, what we did is we treated our data, and then again we tried two models. One was logistic regression, other one was decision tree, and basis on that we had a comparative view on this classification report. So on decision tree gave the better result, where we were able to predict fraudulent data points 90% correctly as per the F1 score. Okay, and if you look at recall, then it was 89% and precision was 92%. So I just hope that all these 3 points are clear to you. Like I said, just in case of any doubt, please put that into the comment section. I'll be more than happy to help you. Thank you very much for watching the video. Wish you